Okay, and I'm going to put parentheses around this. It's I3, and the whole thing is carried in charge of -1. Okay, I don't mean each iodine is carried -1, as you guys normally think. If you had an iodine just hanging out by itself, and I say it's got a charge, you say -1. This is something different. Okay, I look at that. Rule 4 is at play. So that means if Rule 4 is at play, because we've got a halogen here, it's a heavier halogen, or it's from that magic group of 16.
So that's how we know when you use Rule 4 is whenever it's part of the block.
Yeah. Now, we're going to share how many?
4 electrons.
Brittany's saying 4. And most of my students would sit out there and say 6. Okay, this is the different story. Brittany's right. Let me show you why she's right. The cases that we have just done, we had a central atom. These guys are hanging out around the central atom. So you told me share at least 10. 4, SF4. We've got a central atom. These guys are hanging out around. Share at least 8. Okay, over here, one of these guys has to be designated as a central atom. Okay, so, here, let me just make it different. It'd be having an I, and then an I2, and the whole thing. Now, I don't know if that's a good way to do it or not, but you've got to take one of these guys to be your central atom. You're going to have 2 of them around, so we're going to share at least 4. And that's a tricky, tricky, tricky one, because you've got to realize you don't have a clearly delineated central atom here, Nina.
So it does actually matter the shape then, because when you do it in a linear form, they share.
It'll just be like 1 and then
They-
2 diagonal.
Here.
No, but when you do it in a triangular form with the 3 of them, they do share
You're not
3. But
going
when
to
you
have
do
a
it in a
circle.
linear form,
You're not going to have a circle.
okay. 'Cause I
Of course, in chemistry, anything is possible.
yeah, when I first looked at it, I did it that way, and then I couldn't do it, so I did it that
The
way.
reason this is bad news, and this is beyond what you all have heard from me, there's this so-called ring strain that we don't, in order to form a bond, this is more than you need to hear right now, but if you're interested, stay tuned. To form a bond, you have to overlap orbitals. Okay, I want to bond with Andrew. I got to stick out my atomic orbital, stick out your atomic orbital. We just bonded. Okay? Well, when you try to bond in that trio, you don't have atomic orbitals, so they're out in the right directions to do that. It's not impossible, but it's called ring strain. Very unstable. You'll see it some in organic, but we don't need to consider, do not consider cyclic compounds in this class, okay? We're going to be, think simple. Linear, okay? All right, so let's not even think about that, because Nina, if you start thinking about these guys going in a circle, playing Ring Around the Rosie or something, you drive yourself nuts. Because bond angles would be bad news. There are good bond angles and there are bad bond angles. And we'll talk more about that hopefully today. All right, we got to start with this, but let's go back. I see, whoops, Rule 4. Write myself a note. Share at least 4, and then we blindly go through that. And remember, when you're headed down through this, we are forgetting Rule 4. We've had a momentary lapse of memory here. So, need. I have 3 iodines, and they each need how many, Russell? 8. Okay, so that is 24. Then, I have 3 iodines, and they each come in with how many, Hina?
7.
7.
I have to do +1.
+1. Why are you telling me +1?
Because it's an anion. Right?
Yes, we have an anion here. This means this whole thing is a unit, this polyatomic ion has stolen one electron from somebody. You take that into account here, and we get 22. If you forgot to do that, if you forgot to do this, and I see, oh, we're getting 21, that should tell you you screwed up. Because you're not going to end up with odd numbers. Because we share electrons normally. You know, that we share electrons in even numbers. We have pairs and so forth. So, if you don't get that one in there, no, there's a problem. So this tells us to share how many? 2. So what do we trash? 2. We trash that. Okay, so I do this. Okay, let's give. This guy and this guy are in the same situation. Meredith, how many more pairs on this guy? 3. And of course, how many more pairs on this guy? 3. How many more pairs on this guy, Emily? 2. And of course, when you're doing polyatomic ions, remember last week I said, I want to see those guys in square brackets, and I want the charge showing. Now, of course, this can sometimes be ambiguous. See, if we didn't have the square brackets, because here we have a line that means a pair of electrons, that means a negative charge. So yeah, it can be confusing. That's why the square brackets. Okay, somebody besides Timothy, tell me, do we have a finished product? Why not, Andrew?
You need 22 freely available, but only.
Okay, what Andrew just said, if you couldn't hear it, we've used 20. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Gotta check here. We've got 22. We got 2 left over. Who gets the leftovers? The central atom. So just draw another one up there somehow. Okay, so questions? How many triples? None. How many doubles?
None.
How many single bonds?
2.
How many lone pairs on the central atom? 3. Excellent. 3. 2 on the top I wrote and 1 on the bottom.